Okay, this is A2Further Maths. We are on chapter 7, which is further calculus, and we're taking our first look then at reduction formula. So when using integration by parts with some integrals, it is sometimes necessary to apply integration by parts more than once, as we'll be doing earlier on this chapter. X squared e to the x is such an example. Suppose you start by calling x squared e to the x the integral I2, because the 2 up here, and let u equal x squared and dv by dx equal e to the x. Du by dx differentiating here is 2x, integrating here is e to the x. So integration by parts, obviously we're going to use this, substitute it in, and you end up that the integral of x squared e to the x, which was your question, equals uv x squared e to the x minus the integral of x squared 2x. Rearranging this wee bit here, obviously you have your x squared e to the x here, that's fine, take away 2. Then you have x e to the x, and we did one like this I think earlier on. So you started off with x squared and you work then down to x, so you do integration by parts again with x e to the x. But because we called this I2, x e to the x, then we can call I1. So if you let I1 equal x e to the x, then I2 equals x squared e to the x, take away 2 upon I1. So by one application of integration by parts, you've found the formula to reduce the I2 to a less complicated one of I1. Suppose instead of starting with 2, you start with n, so I to the n is equal x to the power of n e to the x, where n is a positive integer. Integrating here, we'll let u equal x to the n, so du by dx is n x to the n minus 1. dv by dx is e to the x, so integrating here you get e to the x, and by one application of parts you get I to the n, can't see that, sorry, x to the n, e to the x, so that's your uv part, take away the integral of e to the x, n x to the n minus 1 dx. If you take this n out the front, we get x to the n, e to the x, minus n upon I to the n minus 1. If you've called I to the n up here, then this is I to the n minus 1. So going on to the next wee line here, that means I to the n minus 1, integral of x to the n minus 1 e to the x. So the relation I to the n is x to the n e to the x minus n I to n minus 1, where n is greater than 0. It's called a reduction formula. It has reduced an integral involving n to a similar integral involving n minus 1. By repeated application of the reduction formula, you can often reduce a complicated integral to one of those integrals that you already know how to evaluate. So we're going to take a wee look then at this first example. It should make a lot more sense, I hope, once you see this done here. So we're going to use the wee reduction formula from above. So we're going to use, I'll change pencils here to something a bit sharper. It's exciting times. I to the n is x to the n e to the x minus n I to the n minus 1. That was a reduction formula we just worked out on the previous page. Again, it's up to you to work that out, but that'll make more sense as we run through our examples. And we know that I3 is what we're starting with here, because it's x cubed. So I3, as I said, is x cubed e to the x dx. But we know from the formula above that I to the 3 is x cubed e to the x minus 3 I2, because that takes 1 away. We know that equals x cubed e to the x, take away 3. I2, if we sub it in here, must then be, so I'm going to put this in a big square bracket, x squared e to the x minus 2 I1. That means x cubed e to the x minus 3 upon x squared e to the x minus 2, then I1, which is x e to the x minus I0. We are going somewhere with this, I promise. So I3 then is x cubed e to the x minus 3 x squared e to the x minus 2 x e to the x minus the integral, because we know I0 is going to be the integral of x to 0 e to the x dx. We work our way down until we get one that's incredibly straightforward then to integrate. So what do you get? X to the 0 is just obviously 1, so the integral of e to the x then just gives us e to the x. So now we can start to tie these things up. So if x cubed e to the x minus 3 upon x squared e to the x minus 2 upon x e to the x minus e to the x. I should have my bracket around that, I think, shouldn't I? That gives me x cubed e to the x. Now there's an e to the x in each of these terms here. There's an e to the x here, there's an e to the x here, there's an e to the x here. So we can take out a 3 e to the x. Let's be careful here with this. There's an x squared there. That'll be minus a 2x e to the x. So that's going to be minus 2x. And then that's minus 2 times a minus 1 effectively, so that's going to be then a plus 2. That gives me then x cubed e to the x minus e to the x, and put the 3 back in here. 3x squared minus 6x plus 6. And again, we can take an e to the x out of the whole lot here as our final line. E to the x all upon x cubed minus 3x squared plus 6x minus 6 plus c. So using the reduction formula, there was very little integration actually to do. It was just you're working your way down.